All measurements are estimates of the actual quantity. So the accuracy, because we could always go sort of smaller and smaller and smaller, may depend on the scale of the measuring instrument, the units that it uses, and the person's ability to use the instrument and read the scale. So we can look at the difference between the measurement and the actual value if we have it. So the error could be given, could be positive or negative depending on the measurement, and the absolute value of the error gives the error as a positive number, ignoring the sign. So the percentage error is the error, which is the difference between the measurement and the actual value, and we divide that by the actual value. And to make it a percentage, we multiply it by 100%, or 100 over 1. The limits of accuracy are the smallest and largest possible values that a measurement could be. A ruler with both centimeters and millimeter markings, for example, might produce a 36 millimeter recording. The lower limit would be half a millimeter, that's what this little puppy is, below, and the upper limit would be half a millimeter above. So the lower limit, if we think about it, is the recorded measurement minus 1/2 of whatever that is of the smallest unit. So in this case, our smallest unit was millimeters. So we took half of that and we subtracted it to get the lower limit, and we added it to get the upper limit. Let's look at some examples here. So calculate the absolute percentage error. So percentage error is going to be measured minus actual, right? So that is the difference between those two over the actual. So what is that difference out of the actual? So we have, and we're going to turn it into a percentage, but let's just look. Between 2.9 minus 2.5, that equals a difference of 0.4. So that is our top number, and we're going to take that out of 0.4 out of the actual value, which kind of makes sense because that's the actual and that's the difference, the variable. And so what are we going to do then? So we've got our difference, and we're going to make that into a percentage, and we all know how to make that into a percentage, and that's where we're going to multiply that by 100, which as a fraction is 100 over 1. So we can use our calculator to do this, and that will arrive at a 16%. That is the absolute percentage error based on the difference between those two values, measurement and actual, out of the actual value. Now, if we're going to look at this one, we've got 35 minutes, and the actual is 40 minutes. So the difference between those two, I'm sure you could work out, is 5 minutes. So it doesn't matter if it's positive or negative, but between 35 and 40, there's 5 minutes, right? And the absolute actual value is 40. So that 5 minutes difference out of 40 times 100, and we can do some canceling in here, or we can just use our calculator, and that will give us 12.5, and because we've multiplied it by 100, we know that is a percentage. A single chocolate is weighed, okay, and we get grams correct to 1 decimal place, so we've got 6.7 grams. For the lower limit, we're looking at the measurement, 6.7 minus half of, what is that place? That is the tenths place, so 0.1. So if we look at a number line, if this is 6 and this is 7, and this is a very rough guide, 6.1, 2, 3, 4, 5, 6. If this is 6.7, then we are looking at the halfway points, right? Between these two. So half of 1/10 is 6.65, and the upper limit is going to be the other one of these, 6.7 plus a half of 1/10, or 6.75. Yeah. So if the chocolate's just sold in bags of 10, this makes it a lot easier. So we find the lower and upper limits. So we have 6.7 times 10 equals 67. So now we have 67 grams to deal with, which is a whole lot easier. So our lower limit is going to be equal to 67 minus 0.5 because we're dealing in whole grams, which gives us 66.5. And our upper limit is equal to 67 plus half of whatever our smallest unit is, which gives us 67.5 grams.